This is a pre-built version of the application. So we'll have 4 peers. And this will be the first one, second one, third, and fourth. And each one of the peers will pick up messages coming from all others. So this is the machine name, and this is the port number. So it does its own checking. So even though I'm specifying this peer here, it's not gonna pick up its own messages. Same here and here. And let's go ahead and start mining on each one. So this one succeeded in mining this block, and the other 3 verified it. Now hashing is taking a string of any length as input and producing a fixed length output, and here we are using SHA-256. The one used by Bitcoin, and it produces a 256-bit hash, and since we are displaying in base 16, we end up with 64 characters. And for the purpose of this simple prototype application, we are taking the username plus the timestamp plus a continuously varying nonce plus the schedule with no conflicts that was picked up using a genetic algorithm, and this is in string format. And hashing those, and the proof of work is to have this hash be smaller than the max bound. So this is smaller than this, and we got this from here. So this schedule comes from here. So this is generation 0, and it had the best schedule had 2 conflicts, those 2, and this is a table representation of that schedule. Then we went to generation 1. We're still at 2 conflicts, and we keep going. Until generation 17, and we ended up with this schedule with 0 conflicts, and this is a table representation of that schedule, and this is what we sent to other peers. And the verification is done by each one of those other peers by hashing those 4 values and checking that the produced output is smaller than the max bound. So none of those peers succeeded in finding a hash that is smaller than this max bound. So the proof of work is a piece of data which is time consuming and costly to produce, and this means it needs a lot of electricity that we spend on computing resources, and we also need that other peers can easily verify the result. So we end up spending a lot of energy on trying to solve basically a useless problem. So we are checking if a randomly and continuously generated huge number is smaller than a target number. So the idea of this prototype is to experiment with trying to solve useful problems with part of the energy spent. Specifically here we are using genetic algorithm in order to find a solution schedule with 0 conflicts. So we spent part of the energy in finding this solution. So what I did is to modify the first cryptocurrency project and added genetic algorithm to the proof of work functionality. And we're doing a simplistic approach for now. So we're just using this schedule as part of the block that gets hashed. And the source code here will be available for download. Also a longer version will be available for watching by all channel members, and it will include step-by-step coding plus test running the coded application.